Good day to everyone. We are from Group 6. Before we move into detail, let me introduce our group member, which is me, Liu Aying. Continue with Liu Aipo, Melissa Liao, Abdiaziz, and Shaswani. Alright, let us start with the first part, which is the background of this project. We have been assigned to conduct a detailed design for the beam from an architecture drawing. The selected architecture drawing is a double-story semi-detached house with a modern home design. It is located at Puchong, Selangor. Next, we'll move to the objective of this project. This project aims to design the beam based on the architecture drawing and follow the recommendation of the Eurocop. There are 5 main objectives in this project. The first one will be to design the beam efficiently and to analyze the design of beam. The third one will be to have an exposure to building design procedure according to the Eurocode. Follow with the fourth one is to complete the group project and build teamwork among the group members. The last one will be to understand and apply what we learned through the application. Alright, back with me again with the design calculation. The FB1 is designed with a beam size of 150 by 400 mm. It is designed by using the simply supported French beam method. The characteristic action, which is the GK, is 2 kN per m squared, whereas the variable action, which is the QK, is 2.3 kN per m squared. The design life for this beam is 50 years with the fire resistance of 1 hour and exposure class is at C3. The stud thickness is 150 mm. Unit weight of reinforcement concrete is 25 kN per m cube. The brick wall load is 2.6 kN per m square and the FCK is 30 N per mm square. The FYK for the steel and the link is 500 N per mm square. The bar size that will be used in this beam is 12 mm and 6 mm for the link. For the beam detailing, the end span will have the length of H6 with the spacing of 250 and for the mid span is H6 with the spacing of 100. The reinforcement bar used in this beam is 2H12 together with 1H12. Next is about the FB12. It is designed with a beam size of 350 by 900 mm with the method of simply supported continuous beam. All the characteristic action, design life, fire resistance, exposure class, and the material are same as the previous beam design, except for the diameter of bar. The tension bar will be 25 mm, and the compression bar is 20 mm followed by the shearing is 6 mm. For the beam detailing, at the first span, the length of H6 with a spacing of 250 and the 200 will be used. At the middle span, the length of H6 with the spacing of 400, 425 and 200 will be used. Whereas at the end span, the length of H6 with a spacing of 400, 425 and 250 will be used. The reinforcement bar used in this beam is H25, and there is a lapping due to the length of the beam is longer than 12 meters. Hi, I am Apple. I will continue with the design calculation of FB5A. The beam of FB5A has been selected with a beam size of 200 and 600 mm. This beam is designed as a simply supported continuous beam. All the characteristic actions, design life, fire resistance, and exposure are same as the previous beam, except for the bar size. For the tension bar is 16 mm, compression bar is 12, and the shearing is 6 mm. Alright, now we move to the beam detailing of the FB5A with the length of H6 200 and H6 350 at mid span while the 300 at the end span. The reinforcement bar used in this beam is 2H16. Next, we move to the beam of 16 with the beam size of 150 and 400 mm. This beam is designed as a simply supported French beam. All the characteristic action, design life, and fire resistance and exposure class are same as the previous beam, except for the bar size. For the tension bar and compression bar is 12 and the shearing is 6 mm. This slide shows the beam detailing of beam 16 with the reinforcement bar of 2H12 and the link spacing of 400.
Good morning and hi, my name is Lenny Saleo and I'll present my beam design for FB6 and FB8. Both of my beam was designed according to EC2, starting from the design of flexure down to its detailing for flange beam as the slab is suspended together with the beam. For FB6, the design specification is as shown on the slide, where we have the characteristic actions, its design life which is 50 years, 1 hour of fire resistance, and XC3 class for exposure. The characteristic strength for materials is also provided for both of the design. And the diameter of the reinforcement bar, where given the diameter of tensile bar is 16 mm, compression bar is 12 mm, and for the length is 6 mm. This beam is designed with its size being 300 in width and 600 in its height. Next is the design detailing for FB6, where we can see that on the first span, detail for shearing is provided, where it applied the size 6 spacing 275 and 200 mm for length. For the middle span, same size with the spacing of 325 and 300 for spacing was used, and on the right hand side the length with the same size also as the span before, and its spacing be with 175, 250 and 275 mm. Throughout this 9 meter span, a pair of size 16 tensile bar is used. Now shall we go for my FB8, my simply supported beam design. This beam has a span of 2.4 meter and it acts as a secondary beam. For FB8, the beam design that I've designed is 150 and 250 mm for its width and its height, respectively. And the design specification used is the same as the design that I have mentioned before. And as for the detailing of FB8, I have designed throughout the span a H6 150 mm in spacing for each shearing. A pair of size 16 tensile RC bar is used. And that is all from me. Thank you.
Hi, my name is Shazwani Husna with the Arman. So I will present on my part, which is FB14 simply supported plank beam and FB4 continuous plank beam. So for simply supported plank beam, FB14 using the specification that we got, the parameter on the specification, I got to calculate the effective weight until the last one. I got a detailing for this FB14. So for FB4, I'm using two sizes of beam, which is 150 times 250 and 350 times 650 to beam size. I'm using the specification, calculate all the effective weight until the last one, got a detailing for this FB4.
Good morning, my name is Abdulaziz Ahmoud Samir, CF190185. I would like to present my calculation bar. So my beam is my simple supported beam is FB3. So then I use the size on the beam is 150 and 250 millimeter. Distribution of slab loading from this floor to this beam based on the Ly divided by Lax. So I got 1.6. So if the 1.6 is less than 2, we know the slab is a two-way slab. So I got my continuous beam. My continuous beam is a FB9 or 5' B to D. So this beam is the continuous beam, has a 6 span, having each meter length. So the unity, the primary beam size is 300 times 600 millimeter, and secondary beam size is 230 times 450. Continuous beam analyzing, I choose using moment distribution means, so to determine the moment, because the have a 6 span leaving half in each meter length. So the distribution on the slab for this floor. This floor I go to based on the table 3.15 is a case 4, and this one is a case 2, and this one also case 2, and this one also case 2, and this one case 2, and this one case 4. So I got the shear coefficient of these panels for this value. Thank you so much.
For the conclusion of this project, we can conclude that the project objective has been achieved. Through the application of calculation, this project utilizes engineering knowledge in a practical application and improve technical provision in civil engineering. We have gained a great deal of engineering expertise through the actual application of the calculation, particularly in the area of beam design. Finally, we have successfully finished this project. Thank you. That's all from us.